In the xy plane, the point 3, 6 lies on the graph of the function f of x equals 3x squared minus bx plus 12. What is the value of b? We're dealing with a function that represents the graph on the xy plane. While we will not draw up the xy plane this time around because it's not necessary for us to solve the problem, I hope you have the basic understanding of how they work. If not, please refer to the video on graphs. We are provided a point with coordinates of 3 and 6, and as we know, the first number represents the dimension on the x-axis, and the second one is the y-coordinate. And this is a strict order. We're also given a function that describes how y changes relative to x. And f of x is the function, and the outcome of this function would provide the value for y-coordinate based on the x-coordinate. Having established this relationship, let's replace f of x with y in this function and write it down as y equals 3x squared minus bx plus 12. So this is the same function as provided in the problem, with only difference is that to write it down, we used y instead of f of x. In this form, we have three different variables and unknowns. We have y, we have x, and we have b. Since we already have a certain point that lies on this function, we actually can use two of the three to plug in the numbers. So for y, we can plug in 6 because that point that we're offered has dimensions of 3 and 6. And for x, we can plug in 3. As we put it down, what we get is 6 in place of y equals 3 times, let's replace x with a 3, squared minus b times 3, replacing x, plus 12. If you're wondering why we plugged in 6 and 3 into the function, the answer is easy to understand. The function that we're offered, which is f of x or y equals 3x squared minus bx plus 12, describes every point that lies on the function. And we're given a certain point with certain dimensions, in this case 3 and 6. So this function should apply to this point just as well as it should apply to every other point on the function. And that means that for the value of 6, we can plug in the x value of 3. And in the end, it should add up. And this is how we came to replace y with a 6 and x with a 3. Let's patiently go through the mathematical process. 6 equals 3 times. 3 squared would equal 9. So 3 times 9 minus. Let's reverse the b and 3 just because it's easier to pronounce. Minus 3b plus 12. So this is the same formula as above. It just slightly one step ahead of it. And let's now perform the operation of 3 times 9. And what we get is 6 equals 27 minus 3b plus 12. And at this point, since the b is the item of interest and we're trying to isolate it, let's try to move the other pieces away. So let's reverse the operation of adding 27 on the right-hand side, and let's subtract 27 on both sides. As we know, we need to keep equation intact, which means whatever we do on the right side, we need to repeat on the left side. And also the operation of plus 12 on the right side, let's neutralize it by subtracting 12 from both sides. And what we should get at this stage would be isolated minus 3b. And that equals to 6 minus 27 minus 12. And that equals to minus 33. At this point, we need to take one more step before we isolate the b. Now we need to reverse the multiplication effect. B is multiplied by minus 3. So if we divide by minus 3, what we're getting is minus 3 divided by minus 3 equals 1. And 1 times b equals b. So on the right-hand side, we have b. And on the left-hand side, since we need to divide by minus 3 both sides, what we get is minus 33 divided by minus 3, which is 11. So our answer is B equals 11.